Hi, this is Jamison. I'm going to be covering conversions and right angle vectors today. First, we need to start with a problem. So our problem is this. I need to take the girls to school, but my wife is odd and only knows how much gas is in the car for traveling in kilometers. I know that she said we have enough gas for 6.42 kilometers for a total trip. I also know that the school is 300 feet north at 90 degrees, then turn east at 90 degrees, and go 400 feet. Finally, turn northeast at 38 degrees and go 2 miles. Then we're at school. Question is there enough gas for my wife and I to make it there and home if we took the best distance? What I want to do first is set it up in a graph that's easy to see and can be worked out from there. So as stated in the problem, 300 feet north at 90 degrees, turn east, go 400 feet at an angle of 38 degrees, finally head northeast for 2 miles, and then we're at the school. What I need to figure out is the distance from our house to the school, the best distance, and if we have enough gas to make it. What I want to do first is convert the feet and miles into kilometers, because my wife knows our gas limit in kilometers. So first you take 300 feet, convert that to kilometers with the conversion chart as shown at the top in step 1. So we find 300 feet is equal to 0.09 kilometers. And then what I did is I set 300 feet over 0.09 kilometers equal to 400 feet over x kilometers to find out what 400 feet would be in kilometers. Instead of doing the whole conversion chart, this is another method. So 300 feet is equal to 0.09 kilometers. You cross multiply, you find that 400 feet is equal to 0.12 kilometers. For step 3, you want to convert 2 miles into kilometers. Using the conversion chart, you find 2 miles is equal to 3.2187 kilometers. So once we've got everything converted into kilometers, all we do is set our graph back up, same as before, but have the figures in kilometers. What we're going to do now is solve for right angle vectors. First we need to set them up. At the top left I've got our formulas. I've got the first formula is distance is equal to the x squared plus y squared. Then you take the square root. I've also got finding side y is equal to taking the sine of an angle, multiply it by the hypotenuse, and that'll give you the distance of side y. The distance of side x is equal to taking the cosine of an angle and multiplying it times the hypotenuse. So first, with our first step, we take the bottom left triangle. We went north at 0.09 kilometers and we turned east at 0.12 kilometers. Well, we use the distance formula for this to get the hypotenuse. As shown on the bottom, you take 0.09144 squared plus x side, which is 0.12192 squared. Take the square root and you get the distance of r is 0.1524 kilometers. Then for the top triangle, we actually need to set this one up as a vector and use the sine and cosine methods for solving this. So what I've shown you on the bottom right here is you take the sine of angle 38 times the hypotenuse, which is 3.2 kilometers, multiply them to get side y is 1.9 kilometers. You do the same with x and you come out with 2.53 kilometers for x. Now what I've done to finalize it to get our overall picture, because we need to know the total distance, and we know that the distance formula is, not the distance formula, but we know that x3 would be x1 plus x2 equals x3, and y3 is y1 plus y2. So what I've set up here is in blue, on the left I have y1 and x1. y1's vertical, x1's horizontal for the left triangle, and then the right triangle, x2 is horizontal and y2 is vertical. So we know that x1 plus x2 is going to be equal to x3, which is the large portion of the horizontal piece of the large blue triangle, which is denoted with blue dots, and y1 plus y2 is the large portion of y3 for the large triangle. So, and d is going to be the total distance for the hypotenuse on that large triangle, and that's what we need to find, d, to determine if we're going to have enough gas for our trip. What I did next here is just denote further x1 plus x2 equals x3. Those are the conversions. x1, which is 0.12 kilometers, plus 2.53 kilometers gives you an x3 distance of 2.65 kilometers. And y1 plus y2 is equal to y3, so 0.09 kilometers, plus 1.98 kilometers equals y3 at 2.07 kilometers. You plug it into the distance formula. x3 squared plus y3 squared gives you a distance of 3.37 kilometers once you take the square root of those two added together. So we know that our distance of our hypotenuse on the large triangle, our total distance from home to school if we took the best traveled method, would be 3.37 kilometers. You then can establish distance is 3.37 kilometers. But we know that we need to go 3.37 kilometers back, so our total distance will be 6.74 kilometers. My wife said that we had 6.42 kilometers worth in gas. We obviously don't have enough gas to make it there and home. We dropped the kids off, but we won't make it back. Looks like we need to stop at a gas station. Thanks for listening. I hope you understand conversions and right angle vectors a little bit better now.